Hi there, welcome to this tutorial. Today I'm super excited to walk you through a data analysis project where we will predict a car selling price using Python and machine learning. So let's get started. First, I'm just importing the necessary libraries. So let's go through them. Okay, now let's import the dataset. For this, I need to go here and then select the data and open. Now let's read the dataset by using pandas. So df equal, so let's copy the path and paste it over here and print the df. Okay, so the dataset contains information about various cars, including their names, manufacturing year, selling price, present price, kilometer driven, and many more, right? Now let's see the shape of this dataset. So df dot shape. Okay. So this dataset contain 9 columns and 301 rows. Let's see the information. So df dot info. Okay. So here we can see it has 301 entries and 9 columns, and all the columns names with their data type, right? Okay, now let's see the describe. Okay, what this dataset is describing. So df dot describe, and this would be include equal number. This would be include. No, I just took like this. Right, let's execute. Okay, so here are my columns that are numerical, that contains numerical values. Now let's see the that columns which contains the object column, right? So for this I need to just copy this and paste it and change it by replacing the number into object. Okay, so yeah, car names occurs 301 and there contains 98 unique columns, unique values. Okay, nice. Now let's check the unique values of car name columns. So since car names contains 98 unique categories, and this number of categories is very high compared to the number of dataset samples, right? So it is better to drop it. Okay, now let's calculate the age of the each year, right? So we do this by subtracting the car's manufacturing year from the current year and add with 1, and then we drop the original year column since we no longer need it, right? So finally we display. Okay, now let's set up our plotting environment and visualize our data using the box plot. Okay, so we start by setting a dark grid and style for our plot and define a custom color palette with green, right? And green, blue and orange, these three. Next we create 2 multiply force grid of subplot with a specific figure such as resolution. So we order our columns, so the numeric columns come first and followed by the category column. Now we look through each column to create a box plot. For the first 5 numerical columns, we plot their distribution vertically. For the categorical columns, we plot their relationship with selling price horizontally. And we also adjust the label size for better readability. Now, we are identifying outliers in our dataset based on the selling price column, right? We will initialize an empty list to store the list of outliers and specify selling price as our target column, right? Now, we will look through each categories column, each basically categorical column, sorry. And we calculate the first quartile, third quartile and inertia range of the selling price, and then we define the range for outlier using 1.5 times of the IQR and identify their samples basically outside this range, right? Okay, next we loop through each numerical column. We calculate Q1 and Q3 and IQR for each column and define their outliers range similarly. Now we will identify the samples basically that are present outside this range. Finally, we consolidate all identified outliers that removes duplicates and print the total numbers of outliers along with their indices, right? So the result shows that we have 39 outliers were found in the data set. So here are these, right? So now we are creating a copy of our dataset, that is DF1, and then adding a new column label to classify data points as normal initially. So we then identify and label outliers based on previously identified the outliers, and then we are preparing to remove extreme outliers by listing the outliers where selling price exit 33 or kilometer per driven exit 400,000, and then making these entries as removing in the label column of DF1. Now let's execute it. So we are visualizing relationship between selling price and other features in our dataset using the scatter plots. Each subplots represents a different features plotted against selling price with points like color coded by their classification like normal, outliers or removing, right? So this helps us understand how outliers and extreme values affects the distribution and correlations of the features with selling price. So let's get executed. Okay, so here is our plot. Now we are ensuring that the removing index list contains unique values, right? Now we are performing operation on a copy of the original data frame DF to modify its content based on previously identified removing index. Now let's analyze the frequency distribution of categorical variables using bar plots. So we define 3 categories columns: fuel type, seller types and transmissions. We create a figure with 3 subplots arranged horizontally. Each displays a count plot for one of these columns for the clean data set DF1. We set a custom colors for the plots and iterate through each categorical columns. So for each column, a count plot is generated showing the distribution of categories, and labels and font size are adjusted for clarity. And each bar is labeled with its count using the graph.bar label, right? So the result shows that we have effectively visualized the frequency distribution of fuel type, seller type, and transmission in our dataset. And this provides insights into the distribution of categorical variables. Now, let's explore the distribution of numerical variables using histogram. First, we define a list of numerical columns including age, selling price, present price, and kilometer driven and owner. So this figure is set up with 2 rows and 3 columns to each histogram. We iterate through each numerical column and compute the histogram values and bin edges and plot them using Seaborn's histplot. Each subplot is customized with axis level, grid lines, and annotations for statistical metrics like mean, standard deviation, median, minimum, and maximum values. So the result shows that we have visualized the distribution patterns of key numerical features in our dataset that provides insights into their central tendencies and spreads. Now let's visualize the relationship between the target variable selling price and selected numerical features using scatterplot. We define the features as present price, kilometer driven, age, and owner, right? And arrange them into 2 multiply 2 grid. We iterate through each feature, plotting its values against selling price to observe their distributions. And any potential relationship, each subplot is customized with title, axis level, and grid lines for clarity. So the result shows that we can visually inspect how each numerical features correlates with selling price and provides insight into their potential impact on the target variable. Now let's visualize the relationship between the target variable, selling price, and categorical feature using strip plot. The categorical feature considers are fuel type, seller type, and transmission that displays across 3 subplots. We use strip plot to show individual data points for each category, and that allow us to observe the distribution of selling price within each category. Each subplot is labeled with the respective features named and is formatted with axis labels and grid lines for clarity. So the result shows that we can easily compare how selling price varies across different categories of each feature. This provides insights into the impact on the target variable. Now let's explore the relationship between selling price and present price using a scatter plot. Each subplot is matrix represents different combination of seller type and transmission with fuel type distinguished by color. We use scatter plot matrix to visually examine how selling price varies with present price across various categories groupings. So the result shows that this visualization helps us understand how different factors influence the relationship between selling price and present price. And this considers categories variables such as seller type, transmission, and fuel type. Now let's transform categorical variables into numerical values using one-hot encoding. We create binary columns for each category in fuel type, seller type, and transmission, and dropping the first category to prevent multi-collinearity. So the result shows that each original categorical column is replaced with multiple binary columns where each column indicates the presence or absence of a category. This transformation prepares the data for machine learning algorithms that require numerical inputs. Now let's visualize the correlation between numerical features and the target variable selling price using a heat map. The heat map color intensity and annotations represent the strength and direction of the correlations between different features and the target. So the result shows that darker color and higher numerical values indicate strong correlations. This helps us understand which features might have a significant impact on predicting selling price in our dataset. Now let's prepare our data for modeling by separating the feature X and the target variable selling price from our cleaned data. Now let's split our dataset into training and testing sets using the train test split function from scikit-learn. We set 30% of the data for testing while the remaining 70% is used for training. This ensures that our model is trained on the one subset of the tested and another to evaluate its performance. Now let's set the y-test into the y-test actual variable. Let's execute it. Okay. It is very important that standard scalar transformation should only be learned from the training set. Otherwise, it will lead the data leakage. Now, let's set the linear regression into linear reg variable and then feed the linear regression with x-train scaled data and y-train data. Let's execute it. Okay, now my model perfectly fitted. Now let's convert this into data frame and see the values that are intercept coefficient, right? So here is the data. So intercept is 4.30, present price coefficient is 3.49 and all of others. I will provide the source code in the description, right? So you guys can have it from my GitHub account. Now let's check the model evaluation. For this I am just writing a function for model evaluation. Let's run it. Okay. Now let's see the model evaluation. Okay. So our R2 score is 88%. Now let's use the polynomial regression, right? So for this I am just setting everything in one cell and let's run it. Okay, so I have this, right? Now let's run this and see the y-test prediction, right? By using linear regression prediction. Now let's compare the plot, right? So execute it and call the function, right? Okay, I got my plot. So here we can see the actual values and the predicted values, right? Now let's build a second order polynomial regression. I am just setting the degree as 2, right? So execute it. Now let's see the poly feature names, right? So execute it. 44. Yeah. Now let's split the data set into, I'm just setting is at 30% for test site and 70% for test training site. Okay. Now let's see how much for training shape and how much for testing shape. Okay, so for the training shape, training shape, I got 209 entries and 44 columns. And for the testing, I got 90 rows for the X test data, right? Y is the target variable, right? So that's why we have one column and these are the rows. Now let's do the standard scalar. Now let's set the linear regression into the polynomial reg variable and then feed it. Okay, let's execute it. Okay, our model is perfectly fitted. Now let's evaluate the model. Basically, okay, so I am evaluating the testing size, right? Testing data. So yeah, I got as 98% as R2 score, right? Okay. And now let's see for the test training data set. If I execute it, I got the number. Okay, for the training data, I got R2 score as 97. So yeah, so the result shows that our polynomial regression model performs exceptionally well on both the training and test dataset with high accuracy and low error metric. This strong performance suggests that our model is reliable for predicting car prices. Okay, so by following these steps, we built a reliable model for predicting car prices. This model can be further refined with additional data and advanced technique to enhance its accuracy and performance. So that's all for today. See you in my next tutorial.